Of the three subatomic particles, protons, neutrons, and electrons, which do you think is the most important? You may think that the protons are the most important because they are the ones that determine what type of element an atom is. Or you may think that the neutrons are important because they're the ones that can make atoms of the same element heavier or lighter by being found in larger or smaller quantities in the nucleus. But when it really comes down to chemistry and chemical reactions, the subatomic particle that is the most important is the electron. Electrons are the stars of the chemistry show. That is why we are going to dedicate several lessons to this negatively charged, super speedy, very tiny, elusive particle. You will find out in a later lesson why I call the electron elusive, but why is it the star? An atom's chemical properties rely heavily on the arrangement of its electrons. So before we can discuss just how its chemical properties can be predicted, we first need to learn how the electrons in an atom are arranged. Remember that electrons are negatively charged, have almost no mass, and are located in the electron cloud, meaning that they are found in the extremely large location outside of the nucleus. They are the ones taking up all the space in an atom. And the amount of space they take up will depend on how much energy they have. More on that later. First, it is important to know how many electrons each atom has. We are only going to be discussing neutral atoms in this lesson, so each atom will always have the exact same number of electrons as it has protons. By now, you should be a whiz at determining the number of protons an atom has. If not, let's do a quick review. Find tin on the periodic table. It is on the middle right side and has the symbol Sn. How many protons does an atom of tin have? The answer is 50, which also means that a neutral atom of tin will have 50 electrons. So as the elements increase in atomic number, the number of protons, they are also going to increase in the number of electrons. An atom of hydrogen will have 1 electron. An atom of helium will have 2 electrons. An atom of lithium will have 3 electrons, and so on. Now the thing that makes an atom behave a certain way is not how many electrons it has, but the way they are arranged. Luckily, the arrangement of the electrons in the electron cloud is quite predictable. Let's take a look at this diagram. It may look just like a bunch of numbers and letters in blocks arranged somewhat like the periodic table, but look closer. Do you see any patterns? First, you may notice that the large numbers increase as you move down. This number indicates the energy level of the electron. The higher the number, the more energy an electron will have. You may also notice that in the center of the table, in that sunken-in region, the numbers follow the same pattern, but are one less than the numbers on the towers on either side. Let's see if we can see a pattern with the letters. The letters seem to have a more organized pattern. With the exception of only a few, all of the S's are blocked together on the left tower we will call the S block. All of the D's are in the sunken-in center part we will call the D block. The P's are on the right tower we will call the P block. And the F's are all in the lower island, which you may have guessed is called the F block. The final pattern you may notice is with the tiny superscript numbers. You should see that in the S block they increase from 1 to 2. In the D block they increase from 1 to 10. In the P block they increase from 1 to 6. And in the F block they increase from 1 to 14. The little superscripts are just counting numbers. They represent the quantity of electrons in each number-letter combination. So what does this all mean? Each of these little clusters of numbers and letters represents information about the location of an electron. We go into more detail on what kinds of information in a later lesson. For now, just focus on the numbers and letters. For example, hydrogen, in the very top left corner box, has 1 electron. That electron is called a 1s electron. Helium, in the very top right corner box, labeled 1s2, has 2 electrons. Both of them are 1s electrons. Lithium is in the box that is labeled 2s1. An atom of lithium has 3 electrons, 2 1s electrons and a 2s electron. Are you starting to see the pattern? Let's try a more difficult one. Find aluminum on the periodic table. On this diagram, it is found in the box labeled 3p1. How many electrons does aluminum have? Well, it has 13 protons, so a neutral atom of aluminum must have 13 electrons. Which electrons are they? Well, it has 2 1s electrons, 2 2s electrons, 6 2p electrons, 2 3s electrons, and 1 lonely 3p electron. Do you see how we are always starting with the hydrogen box on the top left corner and moving from left to right until we get to the atom in question? Don't stress out too much about the bottom couple of rows and the island at the bottom. Things get a little trickier down there and you don't have to worry too much about those elements. Let's try one more example before we get to the next step of putting this all together. Find krypton on the far right side of the periodic table. On this diagram, it is in the 4p6 square. Which electrons is an atom of krypton going to have? We will always start at the top left corner in hydrogen. Krypton has 2 1s electrons, 2 2s electrons, 6 2p electrons, 2 3s electrons, 6 3p electrons, 2 4s electrons, 10 3d electrons, and 6 4p electrons. That should add up to 36 electrons, which is perfect because that's how many protons an atom of krypton has. Listing all of these out may seem a little tedious, so we are going to use a little bit of shorthand. This shorthand has a special name called an electron configuration. A configuration is just an arrangement, so basically we are listing the arrangement of the electrons in each atom. So the electron configuration looks like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p6. That little superscript represents the number of electrons in each number-letter combination. Also, notice how we ended with the same notation as the one listed in the same square as krypton. Let's try one more example. Find chlorine on the far right side of the periodic table. On this diagram, it is going to be in the 3p5 square. So we know that its electron configuration is going to end in 3p5. Pause the video and try to write out the electron configuration, remembering to start at hydrogen and keep going until you get to 3p5. You should have gotten this: 1s2, which represents the 2 1s electrons, 2s2, which are the 2 2s electrons, 2p6, which are the 6 2p electrons, 3s2, which are the 2 3s electrons, and 3p5, which are the 5 3p electrons. How many total electrons is that? A total of 17, which is the same as the number of protons. As I mentioned before, we are going to go into more detail on these letters and numbers and what they mean in a later lesson. But how does knowing them help make predictions about an atom? One example is that all atoms that have an electron configuration ending in p6 are all going to be very stable. They won't react easily with other things. On the other hand, atoms with an electron configuration ending in s1 or p5 are going to be very reactive. This was just a brief introduction into the vast world of the electron, and many questions may still be unanswered. But for now, you should be comfortable writing electron configurations for neutral atoms of elements in the first few rows of the periodic table. Keep in mind that an electron configuration is just a representation of the arrangement of electrons in an atom of an element. It is written by starting with the hydrogen box and moving your way across the periodic table, listing the type and quantity of each electron until you reach the box of your goal element.